Okay, let's get started. Today's lesson is going to be on Java methods. And in this lesson, we're going to cover things like static methods with no arguments, no return type, and basically just does something simple like print out some string, but from a method, from a static method. We're also going to cover static methods that return random integers. We're going to overload that static method with a random integer that takes an offset that basically shifts all the integers over 1 or 2 or however many you want to offset them by. We also have some instance methods that we want to deal with as far as passing an integer by value, passing an integer array by reference. And finally, we're going to cover the factorial recursion, where you have the factorial where if factorial 3 is 1 times 1 times 2 times 3, we're gonna do that in recursion with a method with recursion methods. All right. So it looks like most of the Facebook Lives are ready. Let's just get started. All right. Okay, so what we have here is basically just the main method and within a class called main, and we have hello live lessons. So when we run this, it should basically just print hello live lessons, all right? Awesome. Also, what we have coming next is basically declaring and initializing, basically calling to a method from a class that we're going to call static methods. And basically, we're going to have all static methods inside of it. And let's go ahead and do that now. Next, what we're going to do is declare a method inside of it called print's name. Public static void print name. And essentially what this method is going to do is just print out the name of the method, or we're going to say called and then the method name. So print line called, and then we're going to use the method name. All right. So this is our first method that we're dealing with that we created on our own. You might want to note that the system class has an out attribute that has a method called printLine. And we've been using methods all along. Every single time you call printLine, that's calling to a method. So now we're just going to call to our own internal method. So this one is going to be called static methods dot print's name. All right, and let's do one more print line just for maintenance so that everything looks clean. And let's an extra step every time. All right. So it called print's name. And the next thing that I wanted to do was implement the method that returns a random int. So what we're going to do is bring in the package of Java util random. So let's go ahead and create the method now. Public static int random integer. And basically, we're going to call to the random class. So new random next int. And our excluded index, our excluded number is going to be 100. So basically, the random class gives you many options to as far as like next int, next double, and all of these things. And I'm giving it a maximum number that it can go to, or actually a maximum excluded number. So it'll have from 0 to 99 as its option pool. So let's go ahead and import this random, and let's see what the options are. So we have next double, next int, next Gaussian, next long, and so on and so on. So basically, we should get a number between 0 and 99 when we call to this random integer function. So how that looks, basically, we would declare a random int, and we're going to call to the static methods dot random integer. All right, and we're going to print that random int out. So system out print line, and would be the random element. All right. So let's go ahead and run this to see what this looks like. Yeah. Change the UI. All right. So yeah, between 0 and 99, 24 definitely fits the bill. So let's run it again just to show that we do get random numbers. 28, one more time. 16. All right, great. So this method is similar to the print's name, except it actually returns something. Print's name doesn't return anything, and print's name doesn't have any arguments between the parentheses of the function declaration or method declaration. And basically, the same thing happens here. We don't have any parameters or arguments. But we do return an integer in this case. So that's the distinction between these two methods, is that one of them is actually giving back a number and the other one is not giving back anything. All right, so let's go ahead and look into overloading. So method overloading is basically a way to use the same exact method name, but we can add parameters that allow the method to basically be distinguished from, another version of it. So let's copy this guy and let's create a parameter called offset. And notice how we don't have an error in this case because of method overloading. We were able to add this parameter because this is saying that this is a different type of method altogether. Yeah. And just for some insight into that, there's confusion between the two words overriding and overloading. Basically, if we had like a concept like a dog, and then we had a new type of dog or a specified type of dog like a hound, and both the dog and the hound have the ability to bark, the hound can override or basically get rid of the original functionality of barking by saying wolf. The hound can actually, instead of saying wolf, it says bow. Not sure what that means, but yeah. And then the hound also has some new functionality, but this bark and this bark are basically swapped out. So this is the original version and this is the new updated version. Where it does something different than the original version. That's overriding. So overloading is actually when you have the same method name, bark, and then within the same class, or maybe even a different class that extends dog or something of that nature, we use the same name, but we add a parameter. In this case, we add an int num. So the first time the dog barked, it just said wolf one time. But now that we're overloading the method and we're adding a new parameter, we can have the dog say wolf as many times as this parameter passes in the value of. So if we pass in 5, it goes 0, 1, 2, 3, 4. So it says wolf 5 times. All right. So that's basically the difference between, I'm working from home. That's basically the difference between overriding and overloading. All right. So in this case, we're overloading the random integer method with an offset. And this offset is basically going to take the original functionality and we're going to extend it out. So we're going to start, we're going to have our range. Instead of starting from zero, it's going to start from wherever the offset is. And also, we can increase the number of random integers as well. So instead of just 100, if we pass in an offset of, say, 50, we would have a range from 0 to 150 in this case. So let's add an offset in here as well. So this increases the size of the random numbers, and it pushes the start as well. So if we passed in 50, and this is 100, so we add 50, that would be 150. But we start at 50 now. We're shifting from 0 to 99 to 50 to 150, basically, with this offset. So let's see what that looks like in code, or implementing it. All right. We're going to do something similar, but this won't be just random int. This will be random offset. And we're going to pass in the number 50. And we're going to use this offset here. Okay, so let's see what this looks like. All right, so we have 95. Now notice the difference between these two is that the numbers are going to be much higher because the range is from 50 up to 150 now. All right, so let's try it one more time. Yeah, notice that these numbers are much higher than these numbers. Okay, great. So moving along, we should create a new class, and this class is going to deal with like mathematical calculations, like basically changing an integer value and then changing an integer reference, and then the factorial method that we mentioned earlier. So let's go ahead and create a new class called X. And basically within this class, we're going to have a method by the name of accepts value. Public void accepts value. And basically when it accepts the value, it's it's going to be a primitive type, and we're going to call it value. And what the goal here is to make an adjustment to the value, but to show that that adjustment only happens within the scope of accepts value. So that's another thing that we should talk about here today, is the scope. So basically, when you have a starting curly brace and an ending curly brace, that is the scope of that either function or if statement or loop or whatever the case. When we have the curly braces, this is considered the scope of that functionality. In this case, it's a method. So with this, we are going to say value, and then we're going to multiply and equals the value. So value within accepts value changes, but it doesn't change the original value that's going to be passed in to it. So this is passed by value. This is an example of passed by value. All right. So let's go ahead and test that out. So int integer value equals 11. And what we're going to do is print we're going to print the value now, the integer value. Right. All right, and we're going to need this more than once. But we are also going to need to create an instance of mathematics. So mathematics equals new mathematics. This is using the default constructor provided by the object class. So, if you don't know, there's a lesson on Java objects that explains this in detail, but all classes implicitly extend from object. But just for clarity's sake, I'm just going to add extends object here so that we know that this default constructor comes from that class. All right, so moving along, mathematics, and here we're going to say accepts value, and we're going to pass it the integer value. All right, so what the expectation here is that we have 11 as the integer value. It prints out 11, and then it accepts the value, and then it multiplies 11 by 55. So let's go ahead and give one more indication of what's happening here. So we have value accepts value, and value and value. Then let's add one more print line for cleanliness. Okay, so let's run this. Okay, here we go. So basically what we have is the integer value is 11, and it passes it in as the to the accepts value as 11, and then within the scope of accepts value, it multiplies value by 5, and the accepts value becomes 55. But the integer value, because this is a primitive and not an object, it's only passed, it's copied. It's copied into the accepts value, but it's not actually passed by reference where it can be changed where it was initially declared here in integer value. So the integer value is still 11. There's that. Okay, yeah, so 11, 11, 55, and then 11. All right, so moving on, we want to create a method called accepts reference. So the difference between accepts value and accepts reference is that an int by itself is a primitive data type, but if it's an int array, it's actually a reference. It's created with the word new, which we'll see in just a second. But here, let's call this reference. Okay, yeah. And what we want to do is accept the reference And we're going to display just the first index because that's what we're dealing with right now is the first index. And basically, when we create it, you'll see that the first index will also be 11. But you'll see what it looks like after the fact within accepts reference and outside of accepts reference. So let's go ahead and create an int array that is called int array reference, int array reference. We're going to use the word new, which basically makes it a reference. And the contents of the array will be 11, 22, and 33. Right? And we are going to print similar to this, but it's going to be for reference. So integer array reference. And we're going to use this. And we're also going to reuse the arrays.toString and pass that to it. And lastly, we are going to pass the int array reference to accepts reference. Okay, so that's this method here. So basically, we have an int array called reference. It accepts the reference. We're going to show the first position because we're only updating the first position. And then we're going to show the first position again. And then we're going to show all of the array before and then all of the array after. All right, so let's do an extra print down here for maintenance. Okay, yeah. So what we have is the integer array reference starts off with 11, 22, and 33. And we check the position 0, it's 11. We update position 0 by multiplying it by 5. And essentially that changes in the array because the array is passed by reference. So when you update it, it's permanent. It's not a temporary scope restricted update. So with the accepts value, this only happens within this scope. The value stays at 55 within accepts value, but outside of accepts value, it stays 11. But with the reference, with the integer array reference, we have 11 passed in as the first position. We accept that first position, and then we multiply it by 5, and it's permanent. It stays within memory, within the array's reference. All right. Moving along, we have the factorial method to deal with. So the last mathematics method is going to be called factorial, and it's going to use recursion. So basically, we have a public int. We're going to return an int. We're going to call it factorial, and we're going to accept a number to factor, create factors for. Okay, so with recursion, there's a couple of things to address. So we have the base case, and then we have the trailing. Logic. That's not the base case. So essentially the base case is when we reach a point that we know that we're done calling the same factorial method or calling the same method over and over and over again, that would be the base case because we said all right, now that we've called this method so many times, this is our stopping point, and then we need to return back to go back up all the levels. So just as a visual representation of what is about to happen, let's say we have a factorial of 5. Then within 5, we would actually call factorial 4, and so on and so on. So 4, 3, 2, and 1. 3, 2, 1. And yeah, so basically when we get down to 1, that is going to be our base case in the case of factorial. Oh, actually, no, there's one more step. When we get down to 0. But when we get down to 0, that's going to be the base case for our chain of method calls. So recursion is basically when you have a method, you call that method, and then within that method, it calls itself. And basically, so that we don't run into something called a stack overflow, where it just basically calls all the way down into infinity, we need to have something called a base case that stops the recursion calls. So in our case, our base case is going to be if, let's see, if number 0. All right. And when the number equals 0, we're going to print the number 1. And we're also going to return the number 1. Because I want to have a visual, representation of the numbers that got called to, and we're going to show the output of that as well, the end result, the number that is added between all of the method calls. So the trailing logic looks like this: int value equals number times factorial number minus 1. Okay. And we're also going to print the number, but with a comma in the front to kind of separate all the numbers visually. All right. So basically what happens is whatever the number is, when it gets subtracted, because we're printing after the number is used, it's actually going to report the first number, and then the second number, then the third number, then the fourth number. But if we put it before this factorial call, it would report in the reverse order. So putting it after this method allows us to see the order that they were called from here. From the order that they return. So from here to here to here to here to here to here. All right. So I believe one more thing needs to happen. We need to return the value. Okay, and that's the factorial that's calculated. All right, and then we're going to report that value on the console over here. All right, so we have is okay. We're going to do 3 factorials. Factorial 5. So we're going to say mathematics factorial 5. All right. And we are going to print them like such. All right, so let's just print the first one because we're coming close to about 40 minutes. What is this? Yeah, for 36 minutes. Oh, yeah, so I did one thing wrong here. This does not need to be print line, and yeah, in, there we go. Okay, here we go. All right, so 5 factorial is 1 times 1 times 2 times 3 times 4 times 5, and then that total is 120. So 1 times 1 is 1, times 2 is 2, times 3 is 6, times 4 is 24, and times 5 is 120. Yeah. All right. All right. So let's go ahead and do 2 more of those, and then we're pretty much into the Q&A. So let's do 10. Actually, let's just do one more. 10 factorial 10. 10. All right. And I believe it comes out as like 2 million or something like that. Like, oh, is it 3 million? Yeah, 3 million. Okay. Yeah, so basically that's recursion. Recursion allows you to call the same method multiple times. We start off with a 5, and then we subtract 1 here, and we're now at 4, 3, 2, 1, and 0. And then the base case says when the number equals 0, print out a 1, and that's this guy here. And then also return a 1. So that's where the calculation says 1 comes back here with whatever the number was that was called last times 1. So the last number that was called before 0 was 1. So it's 1 times 1. In this case, we have 1 times 1. And then we continue back, coming back up this method called chain, all the way to the last number 5, and then we multiplied all of those together to get 120 in this case. All right, let's check for questions. We have one. How long do primitive variables exist in memory? Define the various scopes of primitive variables. Wow. Okay. So yeah. So basically, what we talked about within the accepts value is exactly that. So the primitive is int here, and we multiplied it by 5, and within this scope, it exists. But outside of the scope of accepts value, it doesn't exist anymore. So what you see is 11 coming in, and the accepts value is 11. We multiply by 5, and then once we exit accepts value, that value is no longer 55. It never changed to 55 because what was passed to accepts value was a copy of the original number. Hopefully that makes sense. All right. Let's see. How does Java programming language pass primitive variables to methods by value or by reference? Okay. So yeah, once again, accepts value is by value, and then accepts reference is by reference. So let's explain the reference side. So basically, what we have with the reference is a way to change the value permanently. So the array that's passed to it is 11, 22, and 33. And we access the first position of the array and we multiply that by 5. Let's see here. And that change is actually permanent because outside of the accepts reference, it basically maintains that 55. So that's in comparison to the accepts value. It doesn't maintain that value, but with the array reference using the new declaration here, this makes it by reference. That allows it to keep that value versus where you use or compared to where you use pass by value here and pass by reference here. All right. How can I make a Java function that accepts any type of variable? Okay, I think I can do that. Let's see. Let's do a static method. Basically, we have to do something that I referred to in the last lesson with collections. The auto boxing that happens with integers and primitive data types is something that can be used in this case. But basically all of the objects or all of the values that are going to be passed to this method that accepts any type of variable are going to have to be objects. So in the case of the primitives, it's going to get auto boxed into an integer object. So let's go ahead and say accepts any. Accepts any type. All right, and object, because all classes extend from object, we can use the word object here. And then we're just going to call the variable name object. And because we're not going to need to do anything special here, let's just print out the object. Let's say object. Right? So basically, we would say static methods dot accepts any type, and then whatever we pass to it, it will print it out here. Some objects don't really have cool toStrings, but let's see what it looks like. Anyway, all right. Let's see. Oh, it's going to print. So static methods accepts any type. And let's just use some of the things that we have already declared here. So let's use mathematics, even though that one doesn't have like a cool toString. I can probably create one. But for now, let's just see what it looks like. It should be the reference to the object. It'll be the class name and then some @ sign and some reference to the code or something like that. So that's the toString for mathematics object. Let's go ahead and pass random int there. So this is where we do auto boxing. So we took the primitive and then it converts it to an integer object. Yeah, so it converts it to an integer object here. All right, so let's run that. And notice that it comes out as 4 because it was auto boxed. Okay, maybe that, okay, let's do one more. And then it's gonna be weird because arrays don't really have a toString. We literally have to call arrays.toString. So this will be another reference similar to mathematics, and it'll have an @ sign and some reference number or reference hash. But that should be helpful. Yeah, so this is what an array, an integer array looks like in the toString. And then this is the reference. Yeah, so there you go. Hopefully that answered your question. Any more questions? No. All right, guys. Looks like that's it. Our next lesson is going to be on Java loops. If you want to make any suggestions on upcoming lessons, you can go to our YouTube page. If you search for live code lessons, it should bring you to our YouTube page. Goodness, there's a lot of those. Yeah. If you go to YouTube directly and then search for live code lessons, you'll be able to access it. Also, if you're on Facebook, you have a link to the YouTube page. Yeah, so if you're on Facebook, you have a link to the YouTube page, and it'll bring you directly here. Something like that. Yeah. Otherwise, this is the link here. All right. You guys have a good night.